So this is the evasion attack on the MNIST data set. So let me go to my Colab and just delete all this old stuff. Okay. And that will import the library and the data we want to use, which is the standard one from the National Institute of Standards. It's a bunch of handwritten digits from the census. And so here, that's done, so we can do this. All right, and that should show you an image of what the data is. It's a bunch of pixels, 784 pixels. All right, an array of images, each of 784 pixels, and here's what they look like to view them as images. And that's the virtue of this data set. You can much more easily understand what it's doing than those colored dots. Okay, those are the images, fives, and I only kept 5s and 9s, and I'm just going to train a model to tell a 5 from a 9. And I have the training data, and I have all labeled with the right label here, so I know what the right answer is. So I'm going to train my model to tell a 5 from a 9. Here it's going to use a support vector machine to do that, feeding in all the pixels as independent data points. So it'll draw a hyperplane through a 784-dimensional space. And so that gets up to 93.6% accuracy. And now we can do an evasion attack. We're going to modify some of the test images so that the model will misidentify them. So we're just going to start with some of the existing images and add some changes in the pixels that will confuse the model using this library that does it efficiently. You can see now its accuracy went from 100% on the 25 I picked, went down to 12% correct. So it's very effective, and here's how they look. All right. Oops, I must have failed to copy. Yep, I missed the last parentheses. All right, so now here's the original image. Here it is modified by adding just a little bit of snow to it. Now it's misidentified as a 5. They're all red because they're misidentified. Adding this little bit of snow made it think that 5 is a 9. It thinks this is a 5. It thinks this is a 5. Not obvious at all. It thinks this is a 9. You know, once again, it wouldn't fool the human, but it fools the model because it found out which pixels it decided to use to do the job, and it chose strange pixels to care about, which are not what a human would care about, because it's not doing it the way a human would. And that's evasion. And so you can try various versions. Here's smaller perturbations that fools it less. You can control how much perturbation you're allowed, how much modification you're allowed. You can try different types. There are different types of perturbations you can try. This one here has sort of quantized dots, so they're just black or white. So instead of having gray dots, you have to put in black and change some of the dots to black, change some of them to white. And again, it doesn't take too much noise to confuse them. Like this, a human wouldn't think this is a 5, but the model thinks it's a 5, and so on. You can try different digits and such. So that just lets you see the poisoning effect. And this is the problem with machine learning. It doesn't think the way a human does, so it makes mistakes a human would not make. And exactly how to cope with that is an ongoing area of research without a lot of success. All right, I'm going to stop that recording.